Hello everyone and welcome back to our channel. Today's video is focused on data structures in Python, and it's a bit different from the previous one if you have watched it. Today we'll be implementing first a linked list class, and then from that class we go ahead and implement two other subclasses which are of course inheriting from the parent class in order to implement stack and queues. Stick around to learn more about stack and queues in Python. Alright, it's time to get started. So let's just open a file here. Let's create a file and say touch linked list.py, and what that is doing is just creating a file for us, an empty one, and then we go ahead and open the file. So we know that this is a linked list implementation, rather stack and queue implementation using linked list. So since we'll be using a linked list, the first we need is a node. First we should have some node, and we should have of course the linked list class, and then we have our stack class here, and then our queue class. So with that in mind, let's just go ahead and implement step by step. And also we need a main function, like our main function, which of course is main for this scenario, and we're just gonna pass. And also make sure, like, whenever we call this, we run this file, we're calling our main function, right? Again, you don't really need a main, like if you wanted to, but just to keep everything clean, yeah, we'll be using the main. So I guess I should zoom in a little bit for it to be clear. So I just need a class node, and what a class is doing, it has an init method, and the init method is taking in self and the data to the given node, and we have the self.data as one of the instance variable of the node, which is equal to the data attribute we're getting from the outside. And then we have the next element to the node, which is another node, but to start with we know nothing about it, right? So it's just gonna be a none value. So that will be it for the node, unless we want to implement some method like get data, but we can easily access the node data by just saying node.data. No need to use the method, but if you want to, yeah, we can do that. And then we have another class called linked list, which is now our beast class, and then it has an init method as well, and it's taking in self and the head, which by default is just none, a none value if we're not getting anything. just keep it none. And then we say self.head is equal to none. And also we need some size, so we need to keep track of the size, how our linked list is growing. And then we come back to some of this method I'm using, like the init. We explain a bit about the init. What is it about? Yeah, because it's a Python render method, and we come back to that to explain more, because we'll be using some of those methods to implement some functionalities during this tutorial. So the first thing we need to push some value, or add if you want to, like better probably. Yeah, let's use add. And we need a self and we need a data, right? And what add is doing is just creating a node, an empty one actually, and saying node using the node class in this case, and then we pass in the data. Just simple. And then we have two scenarios. The first scenario is if you want to add at the head, and the second one if you want to add at the tail. So these are pretty different scenarios. For instance, the first one, if you just want to add to the head, the things that the code that you need to do, like you need to flip the head to be the next to the new node, the new node to be the head. So for that case, we can say, okay, let's get our node dot next value. Remember, the node class has a next value. For instance, our object here, we get access to that as well. So we say node dot next is equal to self.head, saying, okay, whatever value we had for the head, let it be the next to this new node, and then set the self.head, the new head, to be the node itself. And that will be it, pretty much it, if we want to add to the head. So if we want to add to the tail, it's a bit different here, and we're gonna check that in a bit. So if we want to add to the head, to the tail, we need to loop over all the element for node, or let's call it something else since we have node there. For nd in self is referencing the linked list itself. So for each element in self, what we need to do, we're just gonna check if we have reached the end, and we have a lot of ways to check if we have reached the end. We can say if nd dot next is equal to none. What we wanna do, we wanna set nd dot next to be equal to be equal to the node. You see, that's basically saying an example here. If we have 1 linking to 2 and 2 is linking to none, how do we know that we have reached the end? We're just gonna check, like, if the next to this, to the next element is none. Yeah, we just gonna know, like, okay, so the next element is probably the last one. So what we need to do is just say, okay, nd dot next is equal to none. we set it is equal to node, we set it to the new node, and then we can just break off the loop. So yeah, nothing more to add to that. We also need something else. We also need to delete, or we can call it remove, and it's taking self. It doesn't need data. You see, it doesn't need data for sure. And one way to do this, since we're removing, again we can remove from the top or from the end, but here for our linked list we'll be removing the tail of the linked list. And what we're doing, we're looping, saying for node in the linked list, if node dot next equals none, what we're gonna do, we're gonna say node dot next is equal to none, and just get rid of the other part. The same as saying if one links to 2 and 2 links to none, how do we know we have reached the end? So we check if the next to this element has next none, so that we know, like, okay, this will be the last element. So the other way to do it is just say, okay, so make your next, make your next to be none, so that we get rid of these 2 here, for instance. So that is an appropriate example for what's happening here. So apart from adding and removing, I think that's what we need. We need to add and remove, or we might need sometimes we might need the data, actually, because what if we need the data? Sometimes we might need the data, and that we end up changing our code a little bit. So if we getting the data in, we can say, okay, we want to check, like, first of all, before going and looping and doing everything, let's just say if not self.head, we should check that. We should raise an exception saying we cannot remove from empty list, right? That one thing. And then otherwise, we want to check if self.head.data is equal to the data we're getting in. And if that's the case, we're just gonna say self.head is equal to none to remove the content from the list, and then just return, end of the story. Otherwise, if we keep on moving and we just end getting the appropriate result we wanted, so we go ahead and loop now through all the elements, and for each node in the linked list, we're gonna check if node dot data is equal to the data we're getting in. And if that's the case, we want to break the loop, right? We want to break the loop. We know, like, okay, we're done. If that's the case, we're done. And also we need some value, because remember, when we're looping and we need to for example, if we use this example here, when you're looping over these elements, 1 links to 2 and 2 links to none, for instance, or 2 links to 3 and 3 links to none. What we want to do when we're looping, if we want to remove the middle element, we should make sure we keep track of the previous one, because we just do not have information about the previous one for a singly linked list, right? And so in order to break the bounds here, we need to keep track of the previous, and then from the previous we link it to the next of the element we want to remove. So for that specific case, we go ahead and do something like this. We declare a previous value, rather, previous to be just none. You see, it's just an empty node. And then for each iteration, if we do not break throughout the loop, we set the previous to be the node. But if we do break off the loop, we set the previous dot next to be equal to the node dot next. You see, so that in this way it helps us get rid of the current node by setting its previous, by setting a link between its previous and its next node, so that it just goes away forever. And otherwise, if we're not breaking of the loop, we just go ahead and set the previous to be this node, current node we within our current iteration. And that will be pretty much it if we wanted to remove something. So apart from the remove, I don't know if we need something else. We just go ahead and try to run some bit of code here and see how it performs, right? So we're gonna declare a list. Let's call it students, which is a linked list, an empty one. And then what we're doing, we know like the add method of our linked list takes in a data, right? So what we can do, we can say students dot add, for instance, I'll add my name, then we grab another one, say student dot add, we add Elon Musk probably, students dot add we add in, let's say we add in Bezos, and then we need one more student, students dot add, we add in Trump, DG Trump, right? I'm not a Trump supporter, by the way. So after adding that, we need just to print and say list, or say full list, since we have all the elements here. We say full list, and then pass in the students, right? And right here we can print something about the empty list and say empty list and then format it and pass in the students list, right? So this will print us some lists, and then we also need to pop some values. We can say students dot remove and give in the value we want to remove. Let's remove Bezos for this. Let's remove Bezos, and then print the list after one delete, right? And then we format it and pass in the students again. So if you're following, if we run this, you should throw an error technically. Let's just go ahead and run it so that you see by yourself. Python 3 linked list. It's saying students.add syntax error, line 51. Let's go ahead and check that. Let's first set the numbers for them. Line 51. It's saying students.add. What is wrong with me? Linked list. Add. We need self. We need data. Let's comment this first. I don't know why it's giving an error. Oh, I didn't close a print statement, a parenthesis on a print statement. That was terrible. Yeah, and it's also giving another error. What's wrong again? I bet it's another parenthesis. Wait, it should be. Yeah, it is. But after this we're gonna get another error, because yeah, the error I wanted to show you isn't just coming yet because of this other error. Yeah, this is one. They're telling us linked list object is not iterable, because you can't just iterate over an object, and for you to iterate over an object you should tell Python to do so, and we're gonna see in a while how to do such a thing. So let's go ahead and open our linked list again, and since we know that we need to tell Python, so we need to use one of Python methods. They call them random methods, and for this specific case we're gonna use one called iter, which taking the self, and then what it's basically doing is returning back a node each time we iterating over. So it's just shaping this class or the object from the class. It's shaping it in such a way that we're able to iterate over some specific element. In this case this will be nodes. So we just need to set our first node to point to the head, and then while the node isn't none, we can do while node is not none. Some people do this by just quite tedious. We can just do while node yield the node and then set the node to be equal to its next node. You see, that is just a simple Python iterator which will be now which will help us use this operation here for node in self, because self is referencing the object itself or the instance of the class, but then the object isn't iteratable unless you specify so using the Python dunder method called iter. So let's go ahead and run now and see if everything is working fine. And you can see, like, yeah, there is an error saying student don't remove bezels. They're saying arrays cannot remove from empty list. Let's go ahead and see what's wrong with that. What is our remove about? We're saying if not self.head, there is an exception, but this should have a self.head, right? Technically, because when we adding, what are we doing? Yeah, the problem is that when we adding, we're forgetting about the head. What we should check that if not self.head, then self.head should just be equal to the node. Actually, should be down. What we should check like if not self.head, saying okay, if self.head is none, set self.head to be equal to the node we created. Otherwise, you loop over and then create everything that follows, right? Another error saying if node.next is equal to none, it's saying none type object has no attribute.next. There's some check we need to do right there. It should be here. We need something called current, which in this case might be none if we want to, and then for each iteration we can say current equals node, and then once we're done we just say current dot next is equal to node. for instance. And that would be it pretty much. But again, if you wanted to add it at the very beginning, you can use this bit of code here, which is setting the node dot next to the head and the head to the node, and you flip everything around. So let's go ahead and run this and see what it's actually giving to us. Python 3 and then linked list. So yeah, here we go. It's giving us some data, but the issue is now, if you can spot, I don't know, yeah, we're getting objects instead of the inside of it. So we're missing something here, and let's just go ahead and fix that by opening up our file again and saying, okay, since we need the string representation of a linked list, what do we need to do? We need to implement it, and we're gonna use another Python render method, which is called REPR, standing for representation, I believe. And what we're just doing, we're just creating a new list and get it as an empty one, you see. And then we set our current node, or we don't even need to set anything here. We just need to loop over for node in the list, append the data to the node, to the list of element. You append node dot data, and then that will be it. After that, after looping, you need to return something. You need to return a string, for instance, and in this case we'll be using this format, and then you join the string using the list you've just created, and that will be it. So if we go and run, we're getting, first of all, our empty list, which has, as you can tell, which has Cedric, Elon Musk, Bezos, and Donald J. Trump. And then after deleting Bezos, we're having Cedric, Elon Musk, and J. Trump. That just like that, and that's what we're looking for when we're doing a linked list. So let's get back to the file again. Let's get back to the file again and see if there is anything we might fix. For instance, removing some comments, like we don't really need this. Since we're inserting at the end, we don't really need this business here. And then that'll be it for our linked list. Thanks for watching, and let me know in the comment below if you like the video and what you wish could be improved on for the next videos. And if you like the video, please smash the like button and hit the subscribe and turn on the bell notification for future uploads. I'll see you on the next video, which will be about stacks and queues using the list we just implemented. Thanks for watching, and peace.